This is an electroscope. We have two light pieces of metal foil right here that easily move. Since they are metal, they conduct quite nicely, and they are connected to this metal shaft right here. The metal shaft has the ball on top. Now, this casing right here is also metal, so to prevent any conduction of electricity or current or charges from this metal shaft onto the body right here, this is an insulating piece of material. Let's see if I can get that a little bit closer. That is not a good point of view. Into this insulating material right here, which I suspect is bakelite, but I'm not 100% sure. And to prevent wind from messing up, because they are very light, these pieces of foil, we have this glass panel. So now I can get them to move. All I have to do is charge up a piece of PVC, and I touch it, and boom, those pieces of foil moved. So I've transferred electrons from this PVC pipe right here. To get the PVC pipe charged up, I rubbed it with this piece of rabbit fur. And electrons are scraped from the rabbit fur onto the PVC pipe. So the PVC pipe is negatively charged. And so when I bring it close to here, well, actually, let's discharge it and do the whole thing from the beginning. So I discharge it. So basically, the electrons hate each other and they want to get away from each other. As soon as I touch it, the electrons are jumping onto me. Being a large body, they can easily spread out over me and not be aware of the other electron's existence. So I take this piece of rabbit fur and I charge it up. Now this is negatively charged. When I bring it close to here, notice that the foil pieces are starting to move apart. And let's see if we can get a slightly better backdrop for that. I'm going to take this PVC pipe and bring it near the top. And this thing has been discharged because it's humid out here. So I'm going to take this PVC pipe and then I'm going to rub rabbit fur on it. What I'm doing is I'm transferring electrons from the rabbit fur onto the PVC pipe. So I'm making the PVC pipe negatively charged. Now the PVC pipe is an insulator, otherwise that the charges would then just get away from each other and they'd flow onto me, but they're not. So now I should be able to demonstrate this unless it's incredibly humid. As I bring the negatively charged PVC pipe near it, I didn't have to touch it and they already moved apart. As I bring it away, they go back to where they were. As I bring it closer, they kind of stuck to each other. There we go. They move apart and they move back together. But now I'm going to touch it, so we're actually going to get some transfer of electrons. Because it's an insulator, I'm touching it in multiple places. And you can definitely see the leaves are spread apart. And when I take this away, they don't immediately go back to exactly the way they were before. It's still maintaining somewhat of a charge. Now, if it's incredibly humid, they're going to, as we're watching it, they should be coming back together again. And so normally this is a great demonstration in January. However, considering this is mid-May, not so much, but it is sort of maintaining it, which is good. If we can establish that the rabbit fur transferred the electrons to the PVC pipe, can we get a positive charge? And how can we test that? So I'm trying a different material here just to see what will happen. So this is the new material that I'm trying. If it's rubbing electrons onto the PVC pipe, then when I bring it near, those leaves should go farther apart. And they do. And let's transfer a few more electrons there. Yep. So I'm now going to take this glass rod and do rabbit fur on the glass rod to see what happens. And notice that they came back together again, which would indicate that the rabbit fur onto the glass rod took electrons off the glass rod, making the glass rod positive. So when it got near it, it drew the electrons up towards it. Let's see if the PVC pipe is still negatively charged. It does seem to be. Not as much, though. Some of it's getting lost into the air because water molecules in the humidity are polarized. All right, make that. It really does not want to stay apart. All right, it's staying apart a little bit there. Let's just make sure that if I touch it, I should ground it. And they do indeed collapse back together again. So let's charge it up again. All right, so scrape some electrons off onto the metal shaft right here. The electrons that are scraped off onto it will shoot down into the leaves, and the leaves will spread apart. Now do rabbit fur on glass. And they do come closer together. Now, not many electrons are being transferred to the glass, but apparently there's enough there. Again, let's ground it. So the next thing I'm going to do is I'm going to take this normal drinking straw and I'm going to rub the rabbit fur on it. So the straw should, I believe, is going to be negatively charged. I'm just going to put it right there. Let's make sure that because of the humidity, I probably need to do this quickly. I've now rubbed the PVC pipe, and so now when I bring the PVC pipe near it, the straw should move away from it. And let's find out if that actually works. Let's get this charged up again. And just a matter of rubbing. And by the way, the Greek word for rubbing is something like tribo or something like that. And so what we're exploring right here is the triboelectric effect. Take the PVC again. And it repels. They are both negatively charged. Now, what will glass do? Let's rub glass against the rabbit fur and bring it near it. And it's attracted. So it gives me the indication that the glass gives off the electrons when rubbed against the rabbit fur, whereas when I do the plastic against the rabbit fur, the electrons are transferred onto here. So that's why this is positively charged, that was negatively charged, and so they attracted to each other. Whereas the PVC and the straw are both negatively charged. And apparently when I touch the glass to it, that messed it up. So let's try this again. The PVC. And it repels. So they are the same charge there. I'm going to rub the straw and the PVC pipe with the rabbit fur. And let's get a fresh piece. If you're concerned about the rabbit fur, this is actual rabbit fur, but all the rabbits from which this was taken were moving to warmer climates and they did not need the fur anymore. So they are all living comfortably on a farm down in the Caribbean. All right. Now the PVC pipe. And it repels, so they are the same charge. So they're both, I believe, gaining electrons. These are gaining electrons, and the rabbit fur is giving up electrons. When I do the glass rod, when I take this glass rod and rub it against the rabbit fur, I believe the glass rod is giving up electrons onto the rabbit fur, and so that these will now attract. I believe the glass rod is giving up electrons to the rabbit fur, making the glass rod positive, and so these should attract. There we go. Not as strong a charge put on this, but there's still some charge put onto it, and they did attract as advertised.